let me show you a new perspective on the inner workings of physics, because I claim a physicist like me is a better fortune teller. Since the answer to the question, can physics predict the future, is physics is designed to do exactly that. Physics serves the purpose of predicting the future. What do I mean by that? And does it imply that physics can actually predict the future? You're pretty good at predicting the future, and also your phone is full of fortune tellers. Your weather app predicts tomorrow's weather, Google Maps predict how long your drive will be. If you drop your phone, you know it's gonna fall down. And if you pour yourself a hot coffee, you know it's gonna cool down. You know this because of course, physics, and maybe everyday experiences, but mostly physics. The laws of physics predict that this is going to happen. At least you need the laws of physics to not only know that your phone is gonna fall down, but also when it will reach the ground, or when your coffee won't be hot anymore. Those are examples for physical systems. Everything obeys all laws of physics. But here, we only need laws from mechanics, and here only those from thermodynamics. Furthermore, the systems have properties, fixed numbers that constrain the laws of physics. Here we can assume that you are on Earth, so gravity is only gravity due to Earth. Here the most important property is the given room temperature. The current position of your phone or the current temperature of your coffee are the so-called current states of the systems. So, the initial state of this system is given by the starting position of your phone, and here it's the initial temperature. Knowing the current state, we can use the constrained laws of the systems to actually calculate any future state. So, we can predict the temperature of your coffee at any time. We therefore also know when it will reach room temperature. In our examples, the systems are both characterized by only one variable, one number that changes its value over time, position and temperature. A specific value of this variable at a specific time is a specific state of the system. But a system can be characterized by multiple variables, for example by multiple positions, as in the case of Google Maps. It depends on your position and the positions of those around you. Considering all those different drivers, the system is no longer that simple. Furthermore, here we also have to deal with more advanced physics. We have to account for effects of general relativity. General relativity tells us that clocks run faster the farther they are from the center of gravity. Whenever we use satellites, we have to correct for that, because a satellite is much farther from the center of the Earth than you, so its time passes faster. Neglecting this, GPS would be wrong by kilometers. Nevertheless, the predictions are pretty good. That's because classical physics, including general relativity, is deterministic. In physics, a theory is deterministic if, given the state of a system at one time, the laws of physics uniquely determine the state at all future or past times. That's great! So physicists can indeed predict the future, if they know the necessary laws of physics and if they are able to measure the current state of the system. And it gets even better. For systems like these, we only need rough values for their initial states. If the coffee was slightly hotter at the start, it will reach room temperature just a little later. That barely makes any difference. Small changes of the starting conditions don't matter. They don't influence our prediction. Well, unfortunately, there are systems where a small change in the initial state leads to a huge change in the final state. I'm talking about complex systems, like weather. That's what the analogy of a butterfly flapping its wings is about. A butterfly flapping its wings in Brazil can cause a tornado in Texas. This analogy wants to tell us that just a small difference in the initial state can change the resulting weather completely. That's why the weather forecast becomes less accurate day by day. Don't get me wrong, weather is theoretically still deterministic. The system follows precise laws, but the system is super sensitive to initial conditions, which means that tiny differences grow exponentially. That's why long-term prediction becomes practically impossible. By the way, the stock market can also be interpreted as a complex system. So unfortunately, no prediction of the future here. But the answer to the question, can physics predict the future, is still yes, but only if we know the system and its current state accurately enough, whereby accurately enough depends on the system and can therefore be quite tricky or even impossible. That's not too bad, I guess. And for a long time, physicists were proud to make the world predictable. Well, until the beginning of the 20th century, when quantum mechanics appeared. Here, particles can be at multiple positions at the same time. They can take different paths at the same time. Or, more precisely, a particle does not take a definite path, but is in a so-called superposition of all possible paths. Only when we measure the particle, one specific path is realized. Right now, the meaning of that does not matter. What matters is that we cannot predict which path a particle takes. We can only calculate the probabilities of possible paths. So we can't really predict the future. We can only predict probabilities. This is the reason a lot of physicists did not like quantum mechanics when it came up, because it destroyed determinism. And this is also the reason why we have no intuition for quantum mechanics, because our everyday experiences are deterministic. So, physics wants to predict the future. In our daily lives, this usually works. Sometimes we don't have sufficiently accurate information and then we insult the weather forecast. And in the case of quantum physics, we are doomed to only predict probabilities. But still better than a fortune teller. If you found this helpful, please like and subscribe. Thanks for watching.